हेलो गाइस, आज हम स्टार्ट करने वाले हैं नॉर्मलाइजेशन ऑफ स्टेट। तो आपने डिफरेंट टाइप की स्टेट देखी होगी, जैसे इन मैट्रिक्स फॉर्म एंड एक्सपोनेंशियल इंटीग्रेशन फॉर्म एंड समथिंग लाइक मोड फंक्शन एंड सम लीनियर कॉम्बिनेशन ऑफ डिफरेंट आइगन स्टेट एंड द नॉर्मल वेव फंक्शन। सो आज हम इन पांचों को इंटीग्रेट करके इनका नॉर्मलाइजेशन कांस्टेंट फाइंड करेंगे और देखेंगे कैसे नॉर्मलाइज करते हैं डिफरेंट स्टेट्स को। तो अवर फर्स्ट क्वेश्चन इज ऑफ साइन इज इक्वल टू ए बी एंड सी। We have to normalize this state. So first of all, we have to convert like this is get psi. Okay, so we have to because this is column na, so we have to convert it in bra state. So bra sign is equal to a into b star, b star, and c star, something like this. Okay. So for the normalization, what is the condition? Sign get bra sign get psi is equal to 1, inner product of that. So this will become a into a star, b star, c star, something like a column vector a b c is equal to 1. So after getting multiplied, I will get mod a square is equal to 1 upon root 1 upon a square plus b square plus c square. Now my a mod is equal to the normalization constant is equal to root a square b square plus c. Okay, that's the first way. Like when you have a matrix representation on column or something like this, you have to get you have to transpose the matrix and conjugate transpose, and after that calculate this thing. Okay, this is the condition of the normalization. In the second question, let's see. In the second question, we have the sine function is equal to exponential of a minus alpha x square. Okay, so what is the way? Like here, and it's also same thing. Sine psi is equal to 1. So for that, what is the nature? Like in this is the wave function. So we have to integrate this in there because this is in x form. Okay, so we will integrate this thing like a into e to the power alpha x square, and this is real, so it will not change. Okay, in the conjugate form, it's also the same thing. So a e to the power minus alpha of x square. This is star dx. So the b1. We will integrate this function, and what we'll get, a is a constant, so we'll taking out a square, and this will get become minus 2 alpha of x square into dx is equal to 1. So we know by the gamma function what is the integration of this value. This integration will become root pi over 2 alpha to the power 1 by 2 is equal to 1. Now my a mod is come 2 alpha over root 2 alpha over pi, well, power pi to the power 1 by 2, because you can see here the 1 by 2 terms. Okay, now and this is the my normalization constant. This should be 1 by 4 because 1 by 2 is there, and this should be okay, I had a mistake, 1 by 4. Okay, and then third question, what is this type of equation? In the third question, we have modulus function. So we have sine is equal to a e to the power minus mod x into alpha, some constant. So what is the way? Like mod x is what? Mod x is generally x and minus x. X is for x greater than 0, and for x less than 0, it will get minus of x. Okay, so for that function we will do like this is an even function, so we can convert like minus infinite to plus infinite a square e to the power minus 2 alpha mod x and dx. So we can convert it in even function. We can say this will become 2a square because 2 factor is coming out and limit changes to 0 to infinite, and it will become e to the power minus 2 alpha x and dx should be 1. Now this is a simple exponential integration, you all can do it. So this is become a square is equal to what is the limit here, and 1 upon e to the power minus 2 alpha x over minus 2 alpha. This is the integration of that thing, and 0 to infinite you will put in the limit, and this will come out alpha. So finally a mod is equal to root alpha. Okay, that's the third question. Now in the next question we have a linear combination of 3 state, that is fourth question. So what we will do in this question, let's see. We have a sine function, and let me erase this. Okay, so we have the sine function like this, 1 upon root 3 u1, 1 upon root 2 u2, 1 upon root 3 u3, like this. Okay, so first of all you have to insert an constant which represent an normalization constant. Okay, so for the finding this we do the same thing which we have done in the before. Okay, what we have done, we have done like In the linear combination, you can directly say like the coefficient square is equal to 1. And you can do one more thing, like get psi you have and calculate the bra psi. And after that, multiply this thing in the product and you will get the same thing. So we are doing the like the coefficient. Where's the if this is C1, this is C2, this is 3. So the formula is saying that C1 is squared, C2 is 3, and C3 square should be equal to 1. So can we say a by 3, like, because a by root 3 will do square, and a by root 2 will do square, and a by root 3 will do square is equal to 1. Now my a square will be taken common now. 1 by 3, 1 by 2, 1 by 3 is equal to 1. Now my a, though a square is equal to 1 upon 7 by 6. So from here I can say my modulus of a is equal to 6 by 7 of root. Okay, that's the normalization of that state. So for that last question, which is fifth question. Fifth question, we have function like a sine function. So we have this function a sine of n by x by l, and this is 0. So this is in 0 to the l, and this is otherwise. Okay. So you have this function, you have to normalize this and find the normalizing constant. So for that we will do the same thing. What is the limit here? So 0 to l. Basically the limit is minus infinite to infinite, but the like other range it is 0, no? So it doesn't matter. We can put directly 0 to l, and here the mod a square, and this will become sine to sine star. Then sine is real, so it doesn't matter. Sine square n pi x upon l. We can directly square for dx is equal to 1. Now what you will do here, you will do the integration of this thing. A mod square taken common out, and 0 to l sine square theta is equal to 1 minus cos 2 theta divided by 2. So we will do the same thing here. 1 upon 2, 1 minus cos of 2 and pi x divided by l and 2 dx. So b1. For this formula, you can calculate this integration, and this will be, I can directly say, because this is well-known integration, this will become out L by 2 is equal to 1. And after this a square is equal to become 2 by L. Now my a modulus is equal to root 2 by L. This is my normalizing constant here.